quantum mechanics describes both light and matter. What is matter? Anything that has mass. What is light? It has a rest mass of 0. Okay, so quantum mechanics describes both light and matter, but with the addition and with special relativity added on top of it, quantum mechanics tells us that the momentum P, what is momentum defined as, guys? Mass times velocity. And momentum is a vector. The wavelength, lambda, and the speed, v, for both matter particles and photons. What have you just written? So momentum needs what? A mass and a velocity. If either of those two things go away, what happens to momentum? It doesn't exist, right? So when light stops moving, what happens to light? It disappears. There is light no more. Light is a very weird thing that only exists as long as it's moving. And the only thing that light is allowed to do is move at the speed of light. If it falls behind the speed of light, even by like a millimeters per second, it disappears. That's a very weird construct of light. Okay, so we have just defined quantum mechanics plus special relativity together to say that both particles and waves, things that we know of as waves and things that we consider particles, can both have waves and particle properties. So for example, they will both have momentas, which is weird for a wave. Or they will both have a wavelength, which is weird for a matter particle, like an electron. And they will also have speed. Well, speed you can have, right? And the weirdest part about this statement is that they will both, matter and waves, will both have these same equations. Do you want to write those down? Okay, so both will be given by the same equations. So for momentum, it will be P equals E squared minus M squared C4 square root divided by C. Does that remind you of an equation you have seen before? So when people write E equals MC squared, I always object to this equation. Why is this not correct? Because this equation, E equals MC squared, assumes momentum is 0. Which for any particle that is moving, the momentum cannot be 0. Okay? So I suggest that instead of E equals MC squared, I would like us to remember E squared equals P squared C squared plus M squared C4. where E is the total energy, where E is the total energy that includes rest energy plus kinetic energy. ER is the rest energy, and E is the kinetic energy. What is kinetic energy? Energy due to movement. So 1/2 mv squared, right? But that is the special relativity, relativistic kinetic energy. So the relativistic kinetic energy, ET, is given by mc squared 1 minus gamma, where gamma is 1 over 1 minus v squared over c squared. And this is called the relativistic kinetic energy. Okay, number 2, wavelength. Wavelength will be given by h over p. Anyone remember what h is? Planck's constant. Very good. How do you go from classical mechanics to quantum mechanics? In order to go from classical mechanics to quantum mechanics, the scale needs to be changed, right? The scale of the wavelength needs to be changed. And in order to do the scaling difference, we add a term to our equations. And that term is the Planck's constant. Anyone remember the formula, the actual number for Planck's constant? It is 6.626 times 10 to the minus 34 joule seconds. Whereas joules is the unit of I'll move this a little. And momentum this is not the classical momentum, but this is the quantum mechanical momentum. So this will become equal to hc over square root of e squared minus m squared c4 by plugging this value in here. Now there's a special name for this wavelength called the de Broglie wavelength. What is a de Broglie wavelength? It is a special name that is given to the wavelength of an electron. Electron is a matter particle, right? And it has a wavelength? And that wavelength is called the de Broglie wavelength. Number 3 is for the speed. So what is speed? Distance over time? Or lambda f, as we talked about, right? For a quantum electrodynamical system, it is actually pc squared over e. Or if we plug all the values in, 1 over m squared c4 over e squared. So you can plug e and p, all of those values in here, and you will come up with this.